while I get the slides, a warning. I am trying to do 2 presentations of 30 minutes each in 25 minutes. You are lucky because I cannot speak so fast in English as in Spanish. Anyway, I have been asked to concentrate on the first one. They are very related. And the slides contain enough information so you can review it later at your own pace. Who I am, very, very quickly, because it explains why we worked on this. I started doing IPv6 training and consultancy in '99. I have done that already in more than 120 countries during all these 18 years. And one of the questions that I usually get from customers when doing trainings is how we deploy IPv6 to our subscribers, which kind of prefix we allocate to them. And this is a question that everybody that has been doing training and consultancy in IPv6 is getting, and there is not a really good consensus on that. So we decided, a group of people, to work on that, and we found that the best venue to publish best current operational practices was a RIPE document. So this is one of the meetings. The document started about 2 years ago, and I think we went through about 10 revisions, 10 public revisions, but many, many internal revisions, and we changed it a little bit, even the wording during our revisions. I will explain one of the words that we decided to use to avoid confusion with people. If you want to find about this RIPE working group, here is the link of the mailing list and the document that I am presenting here, which is RIPE 690. This is the table of contents. I am going straight to the summary. In case I don't have time, at least I have went to the summary. Basically, what we say in this executive summary is, first, IPv6 is not the same as IPv4. In IPv6, you assign prefixes instead of single addresses. We discourage people to assign to subscribers prefixes longer than /56, and we enter in a discussion about our recommendation is basically /48. We also talk about which kind of addresses to allocate to the one links, and we recommend global unicast addresses. And this is the wording that we introduced at the latest stage of the document is persistence. Many people, if you talk about stable addresses or prefix or dynamic prefixes, immediately things in things like DHCPv6 or things like that. We are not referring to that. We are referring to the fact that the user is getting always the same address, never mind which mechanism is used technically to allocate those addresses. Okay, so we use the terminology persistent versus non-persistent addresses or prefixes. I think I can skip this one. So the first point is size of the end customer prefix. Basically, the recommendation, as I just mentioned, is /48, but we also talk about the /56, and we describe why and if something else makes sense. There is always this discussion. If we allocate /48 to every possible human in the Earth during the next 25 years, how many years we can keep doing that? And there is a math that was done by Tony Hain a long time ago that basically said you can do that for many, many, many hundreds of years, probably in the worst case 480 years, which is more than enough. I don't really believe we are going to keep using IP as today we know it in the next, let's say, 50 years. There will be other reasons, not anymore addressing space, to move to different technologies. So it don't make really sense to think that if we make a mistake, we will break again our network in 50 years because there will be a set of other reasons. No worse. I just keep going. I think this is really, really important for everybody to understand. And unfortunately, as you will see in the second presentation or the second part of the presentation, still a lot of people is doing that. How to number the one link? First option, /64 from the customer prefix. This looked at as a very stupid idea about 10 years when I wrote a draft in BCOP and I got a big pushback. But right now, I think it's 69% of the people is doing that, which is a big number. So I recovered that draft that was expired, and I have already a second version, which basically explains there are a lot of reasons to use the first /64 of the prefix, for example, the /48 that you allocate to the customer to do the one link numbering, okay? It's easier. You can do that because there are RFCs that actually request the routers to support that, and there is a specific document which is RFC 6603 that say prefix exclusion. So you allocate by the IPv6 /48, but don't use this /64. So simple. And this is requested by the RFC 7084, which is basic requirements for IPv6 EPs. So all is done. It's just a question of using it. It depends, of course, of how you are doing your provisioning and so on, but in general, it's something that should be supported. If you don't like that, you can go to the basic way that we do in IPv4, which is you use a specific pool for the one links, okay? So a lot of people is doing that, of course, and you need to have some considerations. Again, as I said before, I'm not going to read the slides. You can go through them later on. And in fact, I will suggest instead of reading the slides, going to the document is just 10 pages, but it has a lot of details about why we decided these recommendations. Another alternative is Unnumbered. It has good things, but it has also some not so good things, and in general, we don't recommend using Unnumbered. It's true, and I think it was a comment to a document that come actually from here, from UK, that some hardware may consume more resources if you use numbered links. This is strange. It's like kind of a way of doing the things from the vendor of that device. I think it was a brass doing that thing. So, well, if it's just a single vendor, that's probably something to raise with that vendor, right? ULA, again, there are people that like using ULA. In general, it's not used so much, but we also explain why this is not so good idea. Another question. Are you using /64 or, for example, /127 for the one links? Our recommendation is to use /64, and there are many reasons for that. Again, explain it in the document very well, but I can mention a few of them. One is if you are using managed bridges in the middle of that point-to-point link, how you address those bridges, okay? So this is something that people don't consider. Maybe you don't need today additional addresses, but maybe in the future you may need. So, well, you may want to avoid renumbering in the future. There is a document that it seems to suggest that the best is /127, but actually it's not. What the document is saying, I don't remember the RFC number, but what this document is saying is routers must support that, but it's not telling you to use that way only, okay? It's just to make sure that if you want to do that way, your router will support or will need to support that. Another interesting thing, and I guess everybody knows about that, is in IPv6, it's a good idea in general to assign whatever prefix size you choose to make sure that this aligned with the nibbles, okay? So it's 4 bits boundaries. If you don't do that, you are probably breaking many things and are making things more difficult. More than breaking, you are actually making things more difficult. So just take care about that. And again, the best is at a minimum to make sure that you assign to the customer multiple /64s. That's the basic thing. If you want to choose a very common way, which is I do /48 for business, but I just do /56 for end users. Well, that's an option, but typically it's a marketing or sales tool. It's not really a technical rationale behind that. Okay, so again, we recommend everybody /48, or at least if you don't want to give today to your customers /48, just give them the first /56 of each /48. So in the future, if you want to change, you don't need to remember, okay? So this is the thing, /48 for everyone. Less than /56, well, definitively not recommended. We know that some people is doing that, and you will see in the second part of the presentation, not that many, fortunately, but some. If you count the number of /56 that you have in what you get by default from Drive, which is /29, or you can ask by default /29, we are talking about a lot of subscribers. So why giving them just one /64 or one I don't know, whatever, shorter than /56? It don't make sense at all, okay? There is one specific different case, which is cellular phones. Cellular phones get by default, get /64 for each PDP context. That's also mentioned in the document. And we treat, in the case of broadband customers using LTE, we treat them as standard broadband customers. So we also recommend for broadband LTE routers to use /48 as well. Now, I mentioned already at the beginning of the presentation, we defined this terminology, which is persistent versus non-persistent. Persistent means, for us, making sure that the customer will get the same prefix even if all the system gets rebooted because there is a power outage. Okay, that's basically the thing. So our recommendation, again, is, in this case, and fortunately most of the people is doing very well on that, is making sure that customers get persistent prefixes. There are people that say, okay, it seems that non-persistent is easier. Actually, yes, it looks like easier to deploy non-persistent. But it's more like we get used to what we are doing with IPv4. That's basically the point. But if you realize that in IPv6 you are not doing that, it don't make sense. Because in IPv4, if you change the address, if you are using what typically is called dynamic addresses for customers, the internal network of the customer needs to be renumbered because they are using private space, but this is not the case in IPv6, okay? So if you do non-persistent with IPv6, what happens is that most of the CPEs don't keep in the flash memory what prefix they are using. So what happens is that if the CPE gets rebooted, because the RA times, the machines in the network will remember the previous prefix and will get now a second prefix, but the first prefix is no longer being provided by the one link. So actually the host in the network will break. They will not be able to use for a certain time the previous prefix. So this is something that happens not just in countries where there are very frequent power outages. It happens in my home. I have a power outage typically at least once every week. So if I am using a non-persistent prefix from my ISP, I will get this problem. And if there is let's say, 3 consecutive power outages, there will be 3 consecutive different IPv6 prefixes announced in the network until the lifetime goes 0. Okay, so this is something people don't realize when deploying IPv6 until they start getting problems with people that complains, hey, my network is not working after a power outage. And maybe now is not something very frequent because most of the time we have dual stack, but when it's not dual stack, it's IPv6 only, it will happen more and more often. So this is basically the recommendation. Best choice in our vision is use persistent prefixes. This also gives you some new business opportunities because that means you can provide also, let's say, a stable or persistent DNS services to your customers, so they start using their internal cameras like camera1.customer1.isp.com, okay, or things like that. I think that's a good idea, and you will be able to do a lot more thinking on that. So this was the first presentation. Well, I did well in 15 minutes, not bad. So what happened actually is that more or less at the same time we started working in this document, I started asking in one of the RIPE mailing lists how you are deploying IPv6, because I want to give this answer to my customers. And of course, I know what other of my customers are doing, but not what other people is doing. So I started trying to make an email survey, and I got so many responses after just a couple of days that I decided to make a serious survey. I think I have the link to the survey in the last slide. You will find that. I actually sent this link as a reminder about 20 days ago to the UKNOF mailing list. So I got additional responses from UK. And well, basically, I got up to now from all the world 1,500 responses, more or less, which is not bad. It's a lot of responses. I have compiled some graphics. I am not going through all them, but just point to the most important questions on the survey. Actually, almost 70% of the people responding to the survey is using IPv6 itself, which is a good sign, in my opinion. I got responses that sometimes come directly from end users. Some other times mostly came from the ISPs or employees of the ISPs, so it's really trustable. And I try to, it's a very hand job, manually doing comparisons, looking at who is and so on. I have not been able to automate that, and I really prefer to take a look, let's say manually, to see if the responses make sense, right? So people from different regions is responding. Mainly, most of the responses come from RIPE region, but also from APNIC, a lot from LACNIC. And I don't expect you see this, but there is a pointer here. Okay, well, the last bar is UK, is 159 responses. The other one, the big one, is Brazil, okay? In Brazil, there are 6,000 ISPs, if you don't know. So that explains why we got so many responses. So it's not bad, because actually UK is the second responder in terms of people that responded from a single country. Of course, there is a lot of responses from Japan, US, and Germany, France. Those are more or less the countries that got more responses, but there is a quite good response from UK, and that confirms that the data is quite coherent. It's not just a few people responding and so on. In general, I think most of the regions are doing very well everything, and most of the time they are quite coherent with the recommendations that I did in the previous presentation set. Okay, so it seems that the people really follow what we try to suggest, or that the people got the idea that that's the good way to deploy IPv6. There are a few exceptions of countries that are doing much better, and in general, it's especially in RIPE. And the countries that started earlier, especially Nordic countries like Germany, and Finland, and all these countries where there have been some earlier IPv6 deployments, they are doing much better. And in general, they are doing, for example, /48 in most of the cases, while if you look for countries that started later, they are doing more /56. So that explains that while they get the idea much better, or they maybe have started with /56 and change it to /48 later. Well, whatever is the point, it seems that it matches. Another interesting thing is that in general, we have more IPv6 deployment in, let's say, newer technologies like FTTH. So 35% of the answers come from people deploying IPv6 in FTTH, which is one of the biggest ones, and then follow it with 23% by DSL, okay? Is IPv6 already a commercial service? Yes, for 65% of the people, and what I have done, not with all of them, but many of them, especially the big ones, is I talked to them. It's not a commercial service, but it's something that you are doing. Yes, we have already a trial. So most of the people that responded is because even if they are not providing us a commercial service today, they are already testing it, and they really plan to deploy it in the short time. Some questions about the one prefix. Most of the people, as I mentioned already before, 62% is using /64. Only, I tried to see the number, it's too small for me. Only 7% is using 127, okay? So it makes a lot of sense again. How many people is using, that's the small picture, how many people is using the same prefix, the same /64 from the prefix allocated to the customer is, I think I cannot see, it's too small for me, 69%, I think I mentioned in the first presentation. So 69% of the people is using the /64 for the one link from the prefix, the customer prefix, which it's a lot of people, of course. LAN prefix, well, basically here the point is /56 is being used by 35% of the people, /48 is being used by 23% of the responders, okay? And then we have, and this is the big problem, 33% of the people providing a single /64 to customers. Okay, so this is probably the worst thing that is being done in IPv6 deployment and where we must have our effort. Fortunately, I don't have specific numbers in the slides for UK, but fortunately I remember because I looked on purpose a couple of days ago when updating the slides. This is not happening in general in UK. Okay, so most of this /64 is in Latin America and Asia Pacific, not in the rest of the world, fortunately. So despite how many IPv6 trainings we did in Latin America and Asia Pacific explaining that they should not provide a single /64, they got it wrong. So we need to correct that. And I think that's basically, when we ask about transition mechanisms, there is a curious thing as more and more people is using things like IPv6 only, mainly with 464XLAT, which makes a lot of sense. And I think I am done. Yeah. Thank you very much. I think I was too fast, actually.